So 3.2 is on graphing standard form, quadratics in standard form. And so we've talked about that. You've played with that a little bit in 3.1. So we're just going to focus just on if you're given an equation in standard form. So remember that the y-intercept is our c value at the end. So we're talking about this little guy right here, maybe. Okay. It's where the parabola crosses the y-axis. And it's always that c value. So it's nice because it's easy to find. So I'm just going to write it as 0c. And then we have the vertex. And the vertex is the point where the parabola changes direction. And so that's what we did to solve that HK value. Remember, the axis of symmetry is the imaginary line that goes through the vertex. And maybe we should say the imaginary vertical line so that you remember that it's vertical. So it goes through the vertex. And remember, that is always an equation, and it's x is equal to the h value of your vertex every single time. And then we have the direction of opening. So remember that our parabola is going to either open up or down. When I mean up, I mean that it faces up or down. And that means it's going to go down. And you've got your vertex point, and it's going down from there. Oops, that doesn't look very nice. All right, and remember the way we determine that is the a value. So if a is greater than 0, it goes up. If a is less than 0, it goes down. And a, remember, is this first number in our standard form, so the value right in front. The maximum or minimum, so when we talk about that or look at that, our maximum, we either have a maximum or minimum. It depends on if it faces up or down. So we have a max point, and this is always going to be your vertex point, whether it faces up or down. So if your vertex goes up, then this little point right here is our minimum. It's the lowest point that we have, our lowest y point. If my parabola goes down, then this point is a maximum. It's the highest value of your y value. Probably could write that. Highest y value. Minimum, this is your lowest y value. And so when you look at domain and range, remember domain is the set of x values. So of a function. And remember, with standard form or with a quadratic, the domain is almost always negative infinity to infinity. The only time it's not negative infinity to infinity is if it's bounded, which means the parabola has a starting point and an ending point. It doesn't go on forever, like with these little arrows at the bottom. It's got points. But usually domain is negative infinity to infinity. And range is going to be this set of y values of your function. And with a quadratic, the range is always going to be dependent on if it's a max or a min. So if it's got a max, well, let's go min first. If it has a minimum, then your range is going to be from the k value of your vertex up to infinity. If it's a max, then your vertex, it goes down, so it's going to go from negative infinity up to your k value. Now, that's how I usually do it, but on your computer, they write it a little bit different. So remember, on your computer, they don't do interval notation, which this is interval notation. So you're going to practice both, because on your paper homework for today, I would prefer interval notation, but on your big ideas, you're going to do set notation. And so set notation, if you have a minimum, then basically this is saying y is going to be greater than or equal to k. And this would be y is less than or equal to k. And so this is set notation. And big ideas does set notation. I don't know why, because usually in math we do interval notation. Same thing with domain, which we probably should talk about. Set notation is the negative infinity to infinity. So this is set notation. And then the other way they're going to show it is they're just going to say all real numbers. And that is, oh, I lied to you. This is interval notation. And this is set. All right, so all real numbers is the same thing as negative infinity to infinity, and you're just going to go with it. All right. Just a couple other reminders. To find the vertex up here, remember h is equal to negative b over 2a, and then you solve for k by plugging in h for the x's. We're going to talk about that. You're going to see it, but I just want to remind you that's how we're going to find the vertex. Because when we're graphing just straight from standard form, that's what I want. I want the vertex and I want the y-intercept, and then I should be able to graph. I could also factor to get the x-intercepts if I want to, or if it asks me to do that. So as we move on to example 3, not example 3, just the examples. The first example asks us to fill in the requested information and then draw the graph. And so what we're going to do is we're going to look at our a value, which there's not one, so our a value is 1. We're going to put our b value in, which is in front of the x, so negative 8, and our c value is 7. So once we know this, we look at the direction of the opening. So based off a, because it's positive, we know that it's going to go up. And then we're going to find our vertex. And our vertex, remember, is we're going to figure out our vertex point by going negative b over 2a. So if I look at this, I'm going to go negative b, so the opposite of b. And you can either write that as negative of negative 8, or you can just put positive 8. It's up to you. I'll do it as a step. So this is going to be 8 over 2, which is 4. So I know that my vertex point, or my h value, is going to be 4 something. And so I'm going to look for the something. And the way I find the something is I'm going to look in my equation. So my k value, everywhere there's an x, I'm going to put in the 4 value. So you'll notice that in the parentheses is where my x's are. So I'm going to put in 4 into those spaces, and I can either put that in my calculator. Oh, didn't want to do it that big. So I can put it in my calculator. So we're just going to go parentheses 4 squared, and then it's minus 8 times 4, and then it was plus 7. And we just put it in. It's going to spit out an answer, which is -9. And so that makes us know that k is -9. So when I come over here to graph, I can graph that point. So it says, is it a maximum or minimum? And so because a is positive, it's going to be a minimum. And I'm just going to circle it. And then what is the maximum or minimum value? That's the y point. So it's -9. And then our axis of symmetry is x is equal to 4, because it's always the h value of our point. And then remember, our y-intercept is our c value. So our y-intercept is 0, 7. And now we're going to take all of those and we're going to graph them. So we're going to come over here and we're going to graph our vertex, which is 4, -9. That's kind of squishy. Let's see, 1, 2, 3, 4, 5, 6. We're going to have to extend this. 7, 8, 9. So we're going to go 4, -9. And then we're going to graph our axis of symmetry, which is just through that point. So that's this little dashed line. Okay, and it goes, remember, it goes, it's vertical and it goes through our vertex point. And then we're going to graph our y-intercept at 0, 7, which is here. And notice that that's 1, 2, 3, 4 spaces away. So I'm going to go 1, 2, 3, 4 spaces away. And then we're just going to connect that. And that's going to be a kind of a steep 1, 2, 3, 4. Yeah. And remember, we just connect it with a curve. Now, it's not going to be exact because we don't know where our x-intercepts are, but we're just making a good guess using the points that we're given. With that, then we know the domain. So our domain is -infinity to infinity, or all real numbers, depending on what it's asking, if we're on the computer or not. And then the range is your lowest point, which in this case is -9, to your highest point, and it goes on forever, so it goes up to infinity. If you're doing set notation, then you would say y is greater than or equal to -9. And that's that example. Let's stop the video here and then we'll do video 2.